All right. Good afternoon, everyone. Good afternoon. And thank you for joining us today and coming over to learn about the next generation of smart home. So like many of you here, I'm a technology enthusiast. Enjoy what the technology can do to change the world. And this is a very exciting time for the smart home because between IoT, which is really becoming pervasive, and Gen AI, we're seeing a lot of potential for defining the next generation of smart home and what it can do for us. So can you guys imagine a future where you interact with your home, your coffee maker, any of your devices, your car, your air conditioning, and all of those devices know what you need, when you need it, and then acts on it? How does that sound? And more importantly, is this how your home today works for you? No, of course not. So, well, I do have some good news. That future actually is not very far off. As a matter of fact, I make it my mission of delivering this kind of customer experience and smart home. So my name is Olivier Bernard. I'm an IoT specialist with AWS. And I'm joined today on stage with Mr. Young-Gun Kim from LG and Mr. David Bolt, who is one of our SS. And the three of us will help you discover what the future can hold for the smart home. So what is a smart home? And specifically, what does the future for a smart home look like? So the future of the smart home is the integration of IoT devices, which most of you already have in your home, with AI or Gen AI or AI at the edge to make residential living more efficient, more comfortable, seamless, easy, and help you save money. This is what we refer to as the intelligent experience, or the autonomous living. And that we contrast with connected living, which is what we have today. Devices connected to your home, but not necessarily delivering on what you could do with those devices. As a matter of fact, most IoT devices that device manufacturing ship in their homes don't actually get connected, and people don't use them. So that's a challenge. So when you talk about a home that's convenient, that's a home that understands what you need and automates for you mundane tasks. For example, your morning routine. The alarm goes off, but the coffee machine started about 15 minutes ago. The blinds in a house start going up so that you got natural light in your home. Or you come home in the evening, and the home knows it's you coming home, and therefore the alarm turns off, the lights come on, maybe some ambience music come in. So all of those mundane tasks that feels good are the things that the home should be able to do without you having to say, this is what I want. It should be suggested to you. It's also a home that's secure. And by security, I mean the ability to monitor your home for anything that could happen, whether it's intruders, whether it's leak, water leak detection, gas detection, so that you can take immediate actions. And you can do this remotely as well. So if you want to open your door or close your blind or turn on the lights, this all gets done through the smart home. Lastly, it's also a home that can save you money, that understands what you need to use as far as resources, whether it's air conditioning or cleaning your clothes, and adjust what the behavior in your home is going to be depending on the cost of energy. So in the United States, for example, we got hours where energy is higher and hours where energy is lower. So you want to charge your car, your EV, for example, when the cost of energy is the lowest. And so that connected home will say, I get this information from the utilities, and that's when we'll charge. And again, this is a home that will increasingly take advantage of IoT to automate all those processes, to get that intelligence, and to act on your behavior the way you would if you had the time and energy to do so. So today, IoT is everywhere. Most consumers have IoT devices, many of them in their home. So that's not an issue. There's a proliferation. There's over 850 million devices shipped into smart home every year, and that number is going to increase to 5.5 billion devices in homes worldwide by 2030. So the scale is considerable. There's a lot of devices out there that make your life easier. As a matter of fact, 2/3 of US households are considered smart home today. And a smart home is a home that has at least 5 different devices, whether it's streaming TV or smart TV, or smart speakers, smart locks, smart cameras. The average household already has 17 to 21 devices in their home. So with this scale and with this success comes problem and challenges. And the consumers are really not taking advantage of all those devices because it's just too complicated. And there is a lot of different parameters that makes it hard. First is the onboarding experience, setting up your devices, making sure it connects to your Wi-Fi network. Not always an easy experience. Second is operationally, when you have different applications for every single one of your devices, you end up with multiple applications. You forget which devices is being run by what application. It becomes very, very hard to actually leverage all of that infrastructure that you've put in place. And then there is the customer support, right? How many of you have had a chance to say, my device doesn't turn on or doesn't connect to the Wi-Fi. I don't really know why. You get on the phone, and that ends up being an hour to 2-hour conversation explaining what the problems are. So for all of those reasons, we don't see the adoptions of smart home the way we should. Now, because of those problems of setting with the smart home, you have to work for it. And the key word here is work. There's just too many actions to be taken to take advantage of those houses. So we see 3 trends in a smart home that is really going to enable consumer to take advantage, buy more devices, connect more products, having more applications in their home. The first one is invisible automation. So we have to make the onboarding of those devices, the creation of those routines, as automated, as easy as possible. And so by this, I mean, you grab a device, you just plug it in, and here it goes. It connects to your network, and it's part of a routine. And so, for example, if you had a lighting routine in your living room, knows that the light is in the living room, is part of that group, and now it's associated. We had nothing to do. The second one is we need to have better interfaces, right? The ultimate goal when you design a smart home is to have a home consultant or home designer, a human interface that's going to say, well, based on your home and based on the device that you have, this is what I would do. Well, that doesn't exist, or this is not affordable for most people. So right now, what we have is we have smart speakers that you can talk to, but this is not as comprehensive as what you would need to really have a smart home that works for you. So by intuitive and immersive, I mean something happened with your internet. You could talk to your AI assistant and say, hey, my internet is slow. What is going on? What should I do? Should I reset my router? Should I find out what application is hogging all of my data? Or is there just, in the area, an outage, and that's why things are bad? And you would expect the AI assistant to respond in a human favors and say, well, this is what you should do, and this is how you would do it. And that's where we're aiming to be. Once we'll have that, once we'll have automatic, invisible automation and a good interface, then you can go to the next level of the home, which is really where we want to be, which is hyper-personalization. Now, 2 homes are not the same, and 2 consumers are not the same. However, right now, a lot of the application we push to consumers is something that we think most consumer would like. So it's not personalized. It's not personalized according to your preferences, to the devices that you have home, or to the people who are in the home. With AI, understanding the devices that you have, understanding the concept, understanding how people use their home, you can have a really personalized experience for every member of your houses. And once we get to that point, people will see the value of having a smart home and adding more devices to their setup. So if you look here, the recurring theme is really that if you want to scale, you need to leverage AI. Now, AI needs to be the heart of the next generation of smart home. However, the traditional model of AI in the cloud may not work for the smart home for a number of reasons. So what we need to introduce is the concept of Gen AI at the edge inside of your home. And the reason for that is, one, you want to take action with your data as soon as it's there. immediately. You don't want to wait. You don't want to waste some of those data. That data is accessible. You use the data immediately. So for example, if you want to do smart metering and load balancing with your utilities so that you don't consume too much power when there is limitation on the grid, that is something that's done on premises immediately. Same thing, real data processing, analyzing and acting on this data needs to be done according to the context of what's being used, right? So intelligent decision-making, making decision on the spot. There is a leak in the house. I should alert either plumbers or there's an intruder in the house. I go to the ADP company or a security company and report those activities. That is immediate, contextual. You don't have to wait until somebody looked and said, okay, we should do that. In addition, there is regulations. In Europe, they have GDPR, which is a privacy issue. And so more and more, if you want the consumer to trust the system and a smart home, they want to make sure that none of their private data is being leaked to the outside. And so by having Gen AI inside of your home, all of the actionable data is being used inside the home and never leaves. And an example of that is if you've set up your smart camera to recognize your kids, you don't want that inferencing to be sent to the cloud to say, well, those are his kids and so forth. You want this to be all done inside the house like you do everything else. Lastly, what happens if your network is not good enough or not resilient or you have an outage? And Mr. Youngkun will discuss this in his experience because that's a big pain point for his customers. And then lastly, contextual autonomous routine needs to be done also at the edge, and it's based on the devices that you have in your home that are available. It's based on what behavior you have, what do you use, how often, and how. So this contextual learning has to be done at the edge. Now, I've discussed the need for an intuitive AI assistant. And so for the longest time, for 10 years now, we've had smart speakers. That was really helping people interact in a more human ways with their home, right? You didn't have to do programming. You just talk to your Alexa speaker and say, set this up or set that up. And we've built on these successes with screen or smart speakers that have screen, touch screen, that you can interface this. And so the evolution has gone to the point where you have easier way to control your home and to see where your devices are, to display them, but it's not there yet. What is really changing the approach to smart home now is AI and the ability to have those controls set up automatically for you. And that enables you to have appliances that are smart. So you can use now your fridge or your AI mirror to control your home. Now, not so distant future, I think what we want to see is this robot with the sweeper. Right? We want to see that integration of a human-like robot that can carry activities in your home that you don't want to do, but also you want to make sure that when you interact with that robot, it's just like you would interact with a person. And again, we go back to the personal assistant, or we go back to the personal home designers. And by the way, I mean, I believe that in my generation, I will see a robot like this in my home. So that future is not very far off. So there's a lot of use cases for smart home design and for the integration of AI in a smart home. And not one solution fits all of the scenarios and the use cases that you could see. So what we see traditional use cases where you need to use the cloud and the LLMs that are available in the cloud to operate your home. We see use cases where everything's going to be constrained inside of the home, and that's going to be our edge AI cases. And then we see use cases where you need to combine edge AI, intelligent devices with the cloud to provide a comprehensive end-to-end experience. So I'll go through three different use cases or example of how some of our customers have used those architectures to deliver to their customers. So the first one is one of our customers, Electrolux, makes home appliances, cooking appliances, cooktops, and ovens. And so they generated this AI test assist application that allows you to download or scan any kind of recipe that you're interested in, that you want to cook, into your app. The agent will grab that recipe you're trying to make, add the models or the device from Electrolux that you have in your kitchen, send all that information to the cloud. And the cloud, through their master model of cooking, will say, based on the device you have at home, based on what you're cooking and the size and so forth, this is what the cooking profile for that recipe should be. And it will download that recipe back to the appliances, and off you are just cooking without too much risk of overcooking, burning, or creating some other cooking disaster. The second example I will give is now the edge AI, where AI is completely constrained within your home. And that's the case of a smart vacuum cleaner, which has a lot of sensors onto it, a lot of intelligence, and a lot of learning, self-learning algorithms, where once you deploy your robot into your home, it will start mapping your home and figure out which areas are more prone to being clean, which areas are usually pretty clean, so you don't have to go back and forth in the same area. So it creates efficiencies on how your smart robot is going to be used. And that means better energy management for the robot. It means better lifetime for the robot and more efficient cleaning of your home. The third example I will give you is an interesting one that combines an AI agent on a device with the cloud-based AI solution center. And so what we have is we have devices that will run self-diagnostic on themselves and figure out whether there is an impeding failures or something that needs to replace, and will contact our Amazon Connect, which is our call center service, to figure out what needs to be done. Now, this is emulating to some extent how you would call a service center if you have a problem with your device, except in this case, no human interaction is needed. And so in some of the cases, what you'll see is the robot will get that information back and forth and adjust on its own. In some other cases, it will open a ticket and recommend for the consumer to contact the call center. The call center then will be, on the other hand, saying, well, we receive all the information, all the telemetry from your device, and we know what the issue is, and this is what you need to do. Either return the product, either change some of the replaceable within the robot, if you're doing a robot vacuum cleaner, or what have you. The experience here is that you have more time on for your devices, it works better, and when you have an issue, you get a resolution which is much faster. So the consumer experience of saying, okay, now I call the consumer, I know what to do, done. That's a very positive experience for your consumers. Now, deploying smart home solution is not easy because there's so many components that goes into deploying an AI agent, and Mr. David here will go into it. But there's really 4 different dimensions that we look for and we work on to help make this smart home a reality. The first one is there's not a lot of AI embedded devices that are available out there. So there's 2 ways of working with this. One, we work with the semiconductor companies to make sure that they develop the chipset that will be able to sustain AI workloads. But on the other hand, we also work very hard in making sure that we have techniques and frameworks to prune AI models so that they will fit in most embedded type of devices. The second one is complexity of user interface. And if you have smart home or AI assistant at home, you will see that regularly they're being updated with more intelligent features. So the automation of routine is coming to us right now, right these days. The third aspect is we have a lot of consumer devices, and not all those devices talk to each other. So if you want to create routine and link devices to work, such as light with a TV or light with an alarm system, it's not that easy. So the industry has come together to create a smart home protocol called Matter. Matter has been around for about 2 years. They have now a few thousand devices that are available and certified. And so Matter offers this common language for all of those devices to talk the same language and be able to communicate with each other and set up those routines. The latest version of Matter was 1.4, and with 1.4, about 95% of the devices you would find in a home are now Matter compliant. And then lastly, once you've done all of this and your smart home works, it's not the end of the game. You have deployed your IoT workload, or you have deployed your AI workload. You still need to maintain it. You still need to fine-tune it. You still need to customize it to provide that hyper-personalization I was referring to. And so Mr. David will talk about MLOps and some of the service that we've offered for this. So if this seems a little bit overwhelming, there's a lot of things going on, a lot of players. The good news is you don't have to embark on this journey on your own. We have a lot of partners that have devices. We have enabled a lot of AI workload deployed at the edge on different type devices, whether it's IoT gateways or actual devices, such as vacuum cleaners or smart refrigerators. We have customers reference, success references, and Mr. Yunkun will discuss this on how he implemented with his company solution to delight their customers. And then lastly, we have very comprehensive frameworks that you guys can use and leverage on how to deploy those AI workload, what are the best practices, and Mr. David will discuss this with us as well. So with this, let me hand over the mic to Mr. Yungun from LG.
Thank you, Mr. Oliver. Hi, everyone. It's really great to see so many of you here today. My name is Seong Kim. I'm a senior software engineer at LG Electronics, specializing in backend engineering for our smart home platform called ThinQ. I think some of you here might be LG product consumers. Do we have any LG consumers in this room? Great. So many of you here. Great, thank you. But for anyone who might not be familiar with LG, let me give a quick introduction. LG Electronics is the global leader in the home appliance industry. Our products offerings span over 400 distinct categories with an annual production capacity exceeding 80 million units. And of course, you can find our products anywhere in the world. To connect these diverse and powerful devices and deliver true smart home experience, we created ThinQ, our smart home platform. And of course, we're not only connecting to LG devices, but also making it easy for our consumers to integrate devices other brands, such as Matter-compatible devices. To make this even better, we're opening up our APIs. So anyone here working on IoT devices or smart home solutions, we would love you to join us and expand your business. So let's think about what does a smart home experience really look like? Maybe you start right from the moment you make the purchase. So consumers should be able to track their order in real time and know exactly when it's going to arrive. After installation, the devices should recognize them and be ready with the personalized settings. No need to touch a thing. And if it went away, devices could provide a cozy space for our furry friends at home. And when you go out, you could handle tasks like cleaning, turning up the air conditioning, and switching up the light. And wherever you are, we should be able to check our home, see its status, and take actions as needed. Or if there's an issue, the devices should self-diagnose and schedule services and even updates itself with new features, just like your smartphone. The best part? ThinQ is already making this possible. So let me tell you more about ThinQ. ThinQ is all about three main things for our consumers. First, always on, seamless experience, and personalization. First, always on. It's all about giving you constant access to your smart home anytime and anywhere. For that, IoT connectivity is super important. This connectivity allows families to share and access their appliances seamlessly, no matter where they are. And it's not just for LG products. You can connect over 7,000 different product types from various brands, giving you incredible flexibility. The second value, seamless experience. This means a smooth and uninterrupted smart home experience from the moment you buy a product to all the after-sales support. We believe every step matters, from purchase to delivery, usage, and after-sales support. Since we handle all the data from the production to after-sales support, so you can connect your ThinQ right after purchase without any complicated setups. Lastly, personalization. It's about giving each person a custom experience. With ThinQ, you can set up all kinds of automations to do exactly what you want and making your home feel truly smart. Today, I'm here to talk about how we have built and operated this kind of smart home platform on a global scale. So, let's dive into some of the technical details. We've got 3 main stages, each one designed to deliver key customer values. First up is the data ingestion stage. This is where we handle all that IoT data. Our goal here is to process the IoT data as quickly and reliably as possible. Right now, we're processing over 22 billion IoT transactions every day. Next, we move on to the data processing stage. This is where we get the data ready for the personalized services. We're processing massive amounts of data in real time, over several gigabytes per second, making sure it's always accurate, up-to-date, and consistent. Lastly, there's an automation and recommendation stage. This is where we deliver the personalized services, making your smart home experience unique. Okay, let's dive into each stage and talk about some of the challenges we faced and how we tackled them. First, always on. In smart homes, the most critical aspect is connectivity. One of the biggest pain points people have is when their connection is unreliable. Imagine, on a hot summer day, you want to turn on an air conditioning before you get home, but you can't connect it to it through the app. So when you walk in, it is still hot and you are sweating. So that can be really annoying. So one of the biggest challenges in building smart home platform was tracking the IoT lifecycle. But truth is, networks are often unstable. This means IoT devices can easily disconnect, and that's just part of the deal. That's why it is so important to keep track of each device's connection status accurately and in real time so consumers can stay in the loop. Additionally, since we support over 7,000 different product types from various brands, so processing all that diverse data, over 22 billion IoT transactions every day in real time and with stability is no easy task. Plus, most IoT devices use the MQTT protocol, but sometimes we need to switch others like HTTP. So let's take a look at how we tackle these challenges. First, we focused on accurately tracking the IoT lifecycle. Maybe if you use the AWS IoT Core, you know that tracking the correct device's connection status requires using version number to keep everything up to date. Second challenge was the data diversity. With over 7,000 different product types, we deal with a huge variety of data. Each device is having its own unique data field. So let's take an air purifier as an example. It might have around 20 data fields: power, mode, temperature, air quality, and so on. To store these data fields, AWS IoT Core offers a service called Device Shadow. Maybe you know that. But here's the challenge. In the real world, the devices update their status much more frequently than expected. Now imagine we store all 20 data fields in a single device's shadow. But what happens if the devices update all 20 data fields every second? But if the only thing that changes is actually air quality. So do we really need to update all 20 data fields every single time? Of course not. Instead, we partition the data by type and perform incremental writes. So we only update the data that actually changes. This approach significantly reduces the database load and improves the overall efficiency. The second challenge was data diversity. I already mentioned that. The third challenge was the HTTP protocol. So not too long ago, we used to use the Lambda to convert MQTT to HTTP protocol. But when many IoT devices reconnect at once, we call the reconnect storm. So Lambda may reach its throttling limit, so causing errors and affecting the concurrency limits for the entire account. To solve this, we worked with AWS, and our feature requires to lead to the HTTP IoT rule action feature. This change eliminates the issues and help us provide more stable and reliable services. As we worked through these issues, we came to realize just how crucial strong IoT connectivity really is. Tracking the IoT connection accurately in real time and setting up scalable and partitioned databases are critical. Next, seamless experience. So when do consumers feel that their experience isn't seamless? Maybe this may happen with complicated setups or managing repairs become a hassle. And of course, if they feel like the company isn't there to provide ongoing support. So that's big letdown. For OEM's perspective, limited product support or too many steps of use can lead to the loyal consumers drifting away. And without the ability to provide over-the-air upgrades, it is hard to keep new adding values for consumers. So ThinQ is designed as a fully integrated end-to-end platform. When we say end-to-end, we mean it covers the entire product lifecycle, from production to delivery, usage, and ongoing support. Since we manage every part of a product's data from each component to every software version, so consumers, if have any issues or questions, they don't have to worry about identifying their models or finding a replacement parts. And ThinQ can also self-diagnose and schedule services through the app, so consumers don't need to take any extra steps. It's all behind the scenes. This works because we ensure the data integrity and consistency that guarantees smooth and reliable steps from the production to all the after-sales support. To deliver the true seamless experience, managing data across the whole lifecycle is essential, from production to all the after-sales support. Lastly, let's get into the personalization. So what consumers want most in smart home is for it to actually feel smart. But if they have set everything up manually, or if there's a lack of personalized features, it just doesn't feel like true smart home. For OEMs, the challenge is when they can't offer the customized services or are limited to simple and preset features. To solve this, we provide a highly personalized services for each consumers based on a product they use and their specific environment. We recommend automation tasks that they can easily customize. These automations can connect with third-party devices, including Matter-compatible devices, adapt based on factors like weather, time, and location. To deliver this level of personalization, the key lies in efficiently processing large volumes of data. This includes gathering usage patterns and environment and context, and turning the data into a ready-to-use data format that supports meaningful insights. In computer science, there's a well-known phrase, garbage in, garbage out. This means only clean and high-quality data can lead to the meaningful analysis and accurate personalization. Finally, talk about our future plan from here on, let me talk about how we're expanding and enhancing our smart home platform from a back-end engineering perspective. For a smart home platform to truly be smart, the back-end system needs to be intelligent as well. To make this possible, we need a back-end system powered by AI and ML. Right now, in my view, it's time to move beyond DevOps and embrace AIOps. AIOps allows us to build a more efficient and automated operation environment with predictive diagnostic and real-time responses to simplify system complexity. Right now, we're processing over 22 billion IoT transactions every day. But what about next year? 50 billion? And even more. So as our services is growing rapidly and our infrastructure is getting more complex, it is impossible to rely only on human analysis and management to keep everything running smoothly. This is why we need to make our backend system more intelligent with AI. Moving from DevOps to AIOps is essential, and leveraging large language model will be a key strategy to enhance the observability and predictive capabilities. In the future, we see AI predicting the issues before they happen, and suggesting solutions through AI chatbot, and even supporting automated recovery. From data analysis to root cause analysis reporting, every part of this process should be automated. In the end, the backend system is the foundation of any smart home platform. Efficient operations will help us reduce costs and allowing us to reinvest in an even smarter backend. To deliver the true value of the future smart home, our platforms also need to keep getting smarter. With that, let me hand over to Mr. David, who will share how AI and ML can enhance the smart home setups on edge devices.
Thank you. Now that you heard the vision of smart home from Olivier and how LG built their customer-oriented platform, an end-to-end platform, thank you. What are the actual concepts of integrating AI and ML models for edge devices? In general, there are two different options. The first one is remote inference, where the machine learning model is deployed in the cloud, and then the edge device remotely calls or does a remote API call and inferences then the machine learning model. The second option is inference at the edge, where the machine learning model is deployed at the edge device in close proximity to the application which then invokes the machine learning model. They both have two things in common: how they train the model and how they store the data. Because edge devices are typically limited in compute, and the occasional retraining of machine learning model requires substantial more compute than just running the machine learning model itself. The computational power of the cloud is used in both scenarios for training the machine learning model. Also, they use the cloud to have a central place for the aggregated data, as you saw how LG does it for their platform ThinQ. Using the cloud for both allows them to scale for the growing number of smart home devices we see currently. The data flow is conceptually the same for both. The edge device uploads new training data and telemetry to the cloud where it's stored. The training and tuning step then picks up the latest data and trains a new model version where it's then deployed. The difference is, for inference at the edge, there's an additional step where the machine learning model is put on the edge device and is then deployed on the edge device. Both scenarios, of course, have their benefits. With the remote inference and the machine learning model in the cloud, what you get is a centralized model management, which makes it easier to update and track changes. Also, scalability. You can add compute, or you can easily add compute on demand, and also benefit from the computational power you can have. And you get access to more powerful models. Because edge devices are limited, and the most up-to-date models are usually not capable of running on those devices. And with using cloud, also for the inference section, you can design the edge devices to have even less resources and therefore be more efficient. On the other hand, with inference at the edge, at that local latency, what you get is the low latency, so that instant decision-making and real-time data processing. Also, you don't rely on the network, right? You're not limited by bandwidth, for example, for high bandwidth applications like video streaming. Also, imagine a scenario, right? You come home, your smart home, you want to act with your smart home as you're used to, and there are currently connection or network instabilities. You also improve the reliability because by the end, the consumer can still interact with the smart home as he or she is used to. Another aspect is the enhanced privacy and security. Data for inference is not sent anywhere else, and instead it's processed locally on the device itself. And these characteristics can then create that responsive experience the smart home consumer is looking for these days. The 4 key steps in the machine learning lifecycle for edge devices are: you start on the edge device itself with the model inference, you collect the latest training data, you collect telemetry, send it to the cloud. Then the first step is data preparation stage. So you filter your data, you augment it, and prepare it for the training phase. Possibly also, depending on the algorithm, if it's a supervised machine learning model algorithm, you need to do some labeling as well. Then in the training stage, you take in the latest training data and train the new model. Important here is you need to adapt it to your hardware version of your smart home devices, whether it's x86 or ARM, or you might even have different revisions out there in the field, so you need to adapt the model to fit those versions. Then last, you take the model, create your deployment packages, and then deploy them to the edge device itself, where then the edge device picks it up and runs then the latest version. And as you see, it's an iterative process. And what it allows you to create a personalized experience for the smart home user, because it allows you easily to adapt to the new user behavior, because this will change over time. Possibly new routines, or you might have new devices in your smart home system, and then the data needs to be incorporated into the model. Of course, it has its own challenges. And MLOps is a process in order to address those and to automate and streamline the overall life cycle, from development to deployment to maintenance. An important note here is that the development is typically decoupled from the application life cycle, and that gives you the freedom and flexibility to evolve them at a different pace. So the 3 key challenges. The first one is continuous monitoring and improvement. You need to know how good your model is performing on the edge device in order to detect drift and maintain the desired accuracy. On the edge device, it has the added complexity that you have a network in between you can't control, right? So your tooling needs to be able to handle possible network outages or instabilities. And once you know how good your model performs, you also know when to trigger the automated retraining pipelines in order to update the machine learning model to keep that desired performance level. The data, especially the availability and quality you get from the edge devices, lay out the base for recommendations and hyper-personalization. Because you can collect data which is user-specific, which allows you then to train models which are highly granular and on a per-consumer level, which then truly adapts to each consumer's lifestyle. Then the second challenge is, once you have those models, deployment and management. So you need to deploy those models to possibly millions of devices, including versioning of the model, the data, as well as the code. And what it allows you to do is to do blue-green deployments, for example, right? You can test your new model on a small subset of users and then get real user feedback on how your model performs in a real-world scenario. Also very important is privacy and security, right? You need to make sure no one tampered with the model and no one tampered with the data. Because by the end of the day, these models run in the most private area of most of us, which is our homes. The third challenge is resource optimization. So since the edge devices are limited in their resources, you might need to shrink the machine learning model to fit on the devices itself, right? Whether it's through techniques like pruning, quantization, and you want to make efficient usage of the resources you have at the edge. That efficiency doesn't just go for edge devices, but also for all other resources you use, like the cloud resources, for example, for training, as well as for storage. And if you solve these challenges, you most likely will be successful in managing the overall life cycle of machine learning models for edge devices. You can also improve the training or retraining with generative AI. For example, in the data preparation stage, you can augment your data. You can generate synthetic data sets to mimic real-world user behavior, which gives you a first rough judgment how good your machine learning model and your pipelines are doing if there are no real-world user data sets yet. For example, it can support you in labeling, for example, labeling images, proposing a label, and then have a human evaluator either accepting or denying the proposal, possibly cutting the labeling time or the human labeling time in half. It can also support during the training stage, so you can use it for adversarial trainings or generate malicious content in order to mitigate these risks and increase the overall robustness. As well as, especially for text-based machine learning models, you can use concepts like LLM as a judge, so have another large language model come in and evaluate the results. Our solution, which solves many of the challenges I addressed today, is AWS IoT Greengrass, which is an open source edge runtime for designing, building, and maintaining device software. So you create your components. These could be, for example, machine learning artifacts, code for collecting telemetry, or code for running your machine learning model inference. You then create your deployments, whether it's for single things or groups, depending on how you organize your devices. And then Greengrass takes care of deploying these components to the edge device. It reports back the health, as well as the versioning. And if you want to, you can even get detailed log information for each component. It also takes care of the secure connection to the cloud. And it goes bidirectional. So it applies to deploying components to the edge, as well as sending data back to the cloud. It's also often used in smart home gateways. So you have one central device which receives all the updates and then distributes the updates to all devices in the network. We published a solution on GitHub to showcase that end-to-end MLOps for edge devices. What it is, it has a Greengrass instance installed on an EC2 machine, which runs an object detection model, and then it covers the three key aspects of, in this case, the data preparation of labeling images, how to automate this, how to automate the training stage, and also how to automate the deployment, so creating those custom components and then publishing them to the edge device. It's all infrastructure as code, so it's ready to be deployed in any AWS account. So in conclusion today, as we transition from the connected to the autonomous living, the integration of AI and ML will revolutionize the smart home experience. And the foundation is, as you saw today from LG, a resilient and scalable approach to handle connectivity, data coming from the devices, and ensuring the devices stay up to date. This, in combination with an easy and automatic setup, will allow everyone, also non-technical people, to benefit from that elevated experience of a smart home. And the two factors, convenient automation and hyper-personalization, they will not just enhance comfort and efficiency, but will also pave a way for a future where the home intuitively responds to the consumer's needs. If you now feel super motivated to get started, you can work with one of our AWS IoT specialists like I am, engage our professional services, work with many of our AWS IoT partners, or get started with your in-house teams and get started with one of our purpose-built IoT services. That was it from us today. Thank you so much for joining, and please make sure that you rate our session afterwards. Thank you.